This session is on numerical methods. It's part 1. We will look at topics that are covered and know the basics of numerical methods. Please like, share and subscribe this particular channel. Today's session is on numerical methods. It is an approximate fast solution of mathematical problems. We'll be looking at topics that would be covered. In the topics, first we'll be looking at the basics. In the basics, we'll be looking at intermediate value theorem, Descartes' rule of sign. And for the solution of an algebraic equations like f of x is equal to 0, okay, we'll be solving by using a Newton-Raphson method and bisection method and secant method. Coming to solve an differential equations like dy by dx is equal to nothing but f of x comma y. In that cases, we'll be solving by using Euler's method and Runge-Kutta method. And coming into integration method, we'll be using trapezoidal rule and Simpson rule. Okay, we'll be looking at the different type of topics and we'll be solving few problems on it. Coming to intermediate value theorem. Okay, first look at the graph here. There's a line here which is continuous. If you consider this line as an f of x, there's an interval, right, from a to b. When you substitute the value of f of a and f of b, okay, they would be of an opposite sign. Here the value is nothing but negative value. Here it is a positive value, right? Then in this particular equation, there will be at least one root. Okay, say alpha. Then it will be solving this particular value in the equation. Then we'll be getting a value of 0. So intermediate value theorem states that in the interval a to b, such that f of a and f of b are of opposite signs, then there will be at least one root, say alpha. Okay, one more example for it. In this case, there is a graph here. If there is an equation, okay, always the graph would not be given. There will be one equation. So if you consider one of the equation like x cube minus 4x minus 7, here is an x cube, right? So we'll be having 3 roots, right? We're having 3 roots. Now we have to find the intermediate values. In this case, what we do is nothing but first find the value of f of 0. We get as minus 7, which is less than 0. Then find the value of f of 1, which is nothing but minus 10, which is less than 0. See the values here. Both of them are negative. Same sign, right? But they should be enough opposite signs. So these two cannot be an intermediate values. So find the value of f of 2. Then we get as nothing but minus 7. Here also these two are not an intermediate values. Find the value of f of 3. Now we get as plus 8, which is greater than 0. Now these two values are of opposite signs. So intermediate values are nothing but 2, 3. So in between 2 and 3, there will be one root. Okay, it is nothing but intermediate value theorem. Now coming to next topic. Coming to Descartes' rule of sign. Okay, first I'll be showing the rules. Okay, if you consider an equation like f of x is equal to 0, be an nth degree equation. In this case, the first rule is nothing but number of positive real roots always less than equal to number of sign changes in f of x. Similarly, the number of negative real roots always is less than equal to number of sign changes in f of minus x. Okay, it is very important. Now coming to the third rule. If an equation has all the coefficients of same sign except the constant term, okay, it is very important, constant term, then it will be having equation would be having one positive and one negative roots. Okay, now coming to the fourth one. Now they would be having imaginary roots also, right? In the case of nth degree equation, we'd be having p positive roots and q negative roots. Then you'd be having how many imaginary roots is nothing but it is equal to n minus p plus q imaginary roots. Now I'll be showing you a few examples for clear understanding. Okay. Come in the first equation and second equation. Okay. Come in the first equation. It is given a x cube plus 4x minus 7 is equal to 0. Right. X cube is there. Right. Cube means it has an 3 roots. Right. It has an 3 roots. Right. Now in this one, all the terms are positive except the constant term. So we can say that it has one positive root, right, and one negative root. Okay. Now coming to the second one. See here, it is x power 7, right? So it has an 7 roots. It has an 7 roots are there, right? Now we're finding out how many positive real roots are there and how many negative real roots are there. So if you consider f of x, number of sign changes we have to consider. Here it is positive, here it is negative, then positive, then negative, right? Now number of sign changes is nothing but 1, then 2, then 3, right? So it will be having 3 positive real roots, right? Now if you consider f of minus x, here it becomes minus x power 7, right? So x power 5, so it becomes positive, and x cube, so it becomes negative. Here it is negative. Number of sign changes is nothing but 1, 2. So it has 2 negative real roots, right? So in the 7 roots, we have 3 positive and 2 negative real roots, right? Then imaginary roots are nothing but n minus p plus q, right? Here and n is nothing but 7, p is 3, q is 2. So just substitute it, get 7 minus 3 plus 2, which is equal to nothing but it is 2 imaginary roots. We have it, right? This is a way to find the number of roots are there based on a sign changes. Okay, coming to next topic. Now coming to a GATE question. Okay, they given the question in 2013. They given the polynomial f of x is equal to a4 x power 4 plus a3 x power cube plus a2 x square plus a1 x minus a naught with all the coefficients positive. Okay, all the coefficients are positive except the constant term, right? In this case they are saying no real roots, no negative real roots, odd number of roots, at least one positive and one negative root. For this one we know the general rules, right? Descartes rule of sign, right? It has been given here, the third rule, right? All the terms would be having the same sign except the constant term. Then we'd be having one positive and one negative root. So answer for this question is nothing but option D.